The correct circuit connections test has historically proven to be a real mystery. I will explain what the requirements are to do this test and dispel any myths. The correct circuit connections test confirms three things: that earth conductors do not carry current in non-fault conditions, that there is no short circuit between phase, neutral or earth conductors, and that there is no interconnection of conductors between different circuits. To confirm that earth conductors do not carry current by transposition of conductors, the test you do is actually the same as the circuit polarity test and the earth continuity test. So if you've already done them, you don't need to repeat them. If you have done those two tests, the only other thing you need to confirm is that any switchboard other than an MEN doesn't have a link between the neutral and the earth bus bars. This provides a parallel path for current to flow down both the earth and the neutral in the mains. I'm going to wear safety glasses just in case there's any flashover, and safety boots to provide insulation between me and the ground. We're testing for faults, and if there is a fault and you're not insulated from the ground, you're placing yourself in a hazardous situation. Turn off the main switch. Use the prove test prove method to ensure that there's no voltage present, and then lock out and tag out. Remove or switch off all protective devices. I'm just testing one sub-circuit, but if you were testing the whole installation, you would disconnect all sub-circuit neutrals from the neutral bus bar. Before you start, ensure there is no voltage between the disconnected neutral and the earth bus bar. Turn all control switches on and bridge out automatic switches. I'm going to test from the load side of each protective device to the load side of each other protective device, and then test from the load side of each device to the earth bus bar. If you've done the insulation resistance test on sub-circuits, you've already tested between phase and earth, but it's a good idea to double check while we're here. Check the ohm meter reading and confirm no continuity. Disconnect the first neutral from the neutral bus bar and test between it and the neutral bus bar. There should be no continuity. This proves there is no interconnection between neutrals. Then test between the disconnected neutral and the earth bus bar. There should be no continuity. This proves there is no short circuit between each sub-circuit neutral and earth. Reconnect the first neutral and repeat the test for all other neutrals. Now we're going to prove that there is no short circuit between phase and neutral. Turn all protective devices on and put fuses in place, with the main switch still off. Test between each phase and neutral on the load side of the main switch. Check the ohm meter reading. This should be consistent with the load. When testing the resistance between phase and neutral, remember, incandescent lamps and motors can give you an artificially low reading.